Behavior of a monotonic sequence. Prove that monotonically increasing sequence an converges if and only if it is bounded above the limit of sequence an when it converges is a least upper bound of sequence an. Now proof: let the monotonic sequence an converges to L. So given epsilon is greater than 0 however small, there exists a natural number m such that modulus of an minus L is less than epsilon for all values of n is greater than equal to m. So L minus epsilon is less than equal to of less than an is less than L plus epsilon for all values of n is greater than m. Let k is the maximum of L plus epsilon a1 a2 so on am minus 1. So an is greater than less than equal to of k for all values of n. So a sequence an is bounded above converse. Assume that monotonically sequence an is bounded above and u is the least upper bound of an. So given epsilon greater than 0, there exists m belongs to n such that u minus epsilon is less than an is equation 1. Since the sequence an is monotonically increasing, so am is less than equal to of an for every n is greater than equal to m. Equation 2: from 1 n to u minus epsilon is less than an for all values of n is greater than n. Also an is less than u minus an is less than u plus epsilon for all values of n belong to n. So in particular an is less than u plus epsilon for all values of n is greater than equal to m. So u minus epsilon is less than an is less than u plus epsilon for all values of n is greater than equal to 1. So modulus of an minus u is less than epsilon for all values of n is greater than m. So sequence an is converges and its limit being the least upper bound of an.